Okay, on this first slide, we are given a bunch of values for f of x, f prime of x, g of x, and h of x. And it is also telling us that h of x is defined as f of g of x. So first of all, we need to find h of 3. So all I'm going to do is plug in 3 for wherever the x is and what they define for us. So h of 3 would be the same as f of g of 3. And using the table, g of 3 at x equals 3, g of 3 is 2. So this gives me 2. And then f of 2 at x equals 2, your f of 2 is 8. So this value is 8. The next thing I want to do is I want the derivative of h at 1. So step 1, I have to go ahead and find the derivative. So we're going to use the chain rule. So the derivative of h of x is derivative of the outside, inside stays the same, times the derivative of the inside. Okay, so I need to figure out this piece first. So g, and I want to know what happens at 1. So let's plug in the 1. Okay, g of 1, I can tell from the table is going to be 1. So this becomes 1. So all I need to do now is find f prime of 1, g prime of 1, and multiply them together. So f prime of 1 is 3, and then g prime of 1 is 4. So 3 times 4 is 12. Now I want to write the equation of a tangent line at x equals 3. So again, what are the two things that we need to write the equation of a tangent line? We need a point. So I need the y value of h at 3. But again, going back up to the top, h of 3 would be f of g of 3. But notice, we just found it up here. So h of 3 we already figured out is 8. I don't know why I did it again. But there's my point, 3 comma 8. And then I need the derivative. So h prime of 3, and I'm just going to go back to here. I already found the derivative, but I'm going to use 3 instead of 1. So it would be g of 3 times g prime of 3. So g of 3, if I look at my table, looks like it's 2. So now I just need to find these two values and multiply them together. F prime of 2 is 2. And then g prime of 3 is going to be negative 3. So my slope is negative 6. So there's my point, there's my slope. So my equation is y minus 8 equals negative 6, x minus 3 in point slope form.